Hi, today I will share with you a project you can build as a beginner in deep learning. This is a recurrent neuronal network that helps you to classify images with long short-term memory using the most well-known dataset in machine learning field called NIST. By the end of this video, you will understand each step of a deep learning process. You will also have learned how to train a recurrent neuronal network, how long short-term memory works, how to evaluate a model, and even how to create model predictions. The first step is to import all required libraries, in this case NumPy for numerical computations and array operations, Matplotlib for creating visualizations and plots, train test split to divide data into training and validation sets, and warnings to suppress unnecessary warning messages. Second step, to load the dataset and extract the training and testing images. In this dataset, we have 70,000 images. 60,000 will be used for training and 10,000 for testing. Third step, denormalization of the data. We have pixel values from 0 till 255. Therefore, we need to transform them into the ranges from 0 till 1. This is mainly because in neuronal networks, we use activation functions that work with these ranges. And when we encode these values, then this improves the performance of these models. Fourth step, we divide the training data from the test data. In the training data, we separate 80% of the images into training set and the other 20% for the validation set. Fifth step, we take the first 5 images of the training dataset and we confirm that every image is labeled with its correct digit and that the data is loaded correctly. Sixth step, we finally build our recurrent neuronal network model. This model consists on a first long short-term memory layout of 128 neurons to capture patterns. We randomly drop 20% of neurons to prevent overfitting, and we have 2 hidden layers with 32 neurons each for deep learning. And finally, on the output, we have 10 neurons because each image contains digits from 0 till 9. And every of these output layers use the activation softmax. Seventh, how to compile the model. We prepare the model for training by using the Adam optimizer, which adjusts the weights during training. We also use the loss function, which measures the prediction error and metrics as accuracy to track how many predictions are correct. Eighth step, the training of the model. Here, we upgrade the accuracy of the model by each iteration. In this case, 6 iterations called epochs. In each one, the model adjusts its weights, comparing to the validation data and enhancing on each epoch a % of accuracy. For example, with 2 epochs, it has an accuracy of 92, while with 6, it has a 98 of accuracy, which is extremely high. Ninth step, the plot of the training and validation loss curves through Matplotlib library. This is key because the training loss refers on how well the model is performing with the trained data, while the validation loss refers on how well the model performs on unseen data. We have 3 scenarios here: underfitting, overfitting, and good learning. If the model is underfitting, these curves will look like this. Both curves will be high, which means that they are not trained enough, they are not learning because maybe the model is too simple or maybe we require more iterations. If we have the second case, overfitting, the curves will look like this. The training loss will be decreasing while the validation loss will be high because the model is performing well on trained data but not on new cases. The best scenario is when both curves decrease, which means that the model is performing well on new and already seen data. Here we also plot the training and validation accuracy, since we want to see how the accuracy increases through each epoch or iteration. As one of the last steps, we evaluate the model using the library Keras, specifically the class sequential method evaluate, which helps us to test the data on new unseen images using X-test normalized, comparing them with the real labels of those images, which in this case are Y-test. And we also specify that we don't want to print the training process, therefore verbose equals 0. But what does it mean, test loss or test accuracy? Test loss refers to the wrong predictions of the model, while test accuracy refers to the percentage of right predictions. On the last step, we just use NumPy to expand the dimensions of our model, since we want just to predict one image, and the model will not process it well since it's just one. Therefore, we just grab it on a box, so to say, and insert it into the model, where we then use Keras class sequential method predict. It gives us a score for each digit that it could be. For example, 0% probabilities of this image to be 0, 0% probabilities this image is 1, 2, 3, 4, and so on. Then we use again NumPy argmax method to select the highest score. Then we just use matplotlib to show us the image, and that will be it. That's everything it was done on this deep learning process. I hope you guys understood more about this topic and you feel encouraged to continue learning and continue creating and experimenting among all the libraries that are available for deep learning and AI.